In this lesson, we're going to learn how to solve quadratic equations using square roots. The first thing we want to do is identify the squared part of the equation. It'll either be an x squared or it might be a quantity squared, like x plus 1 quantity squared. We want to isolate this part of the equation to begin with. And in order to do that, we'll use the order of operations backwards. Sometimes we will see parentheses and we'll have to deal with those first, but then afterwards, the order of operations backwards, sadly, it spells out sad me. So parentheses, exponents, multiply, divide, add, and subtract. When you're solving, you actually work backwards through there, and the parentheses, it just depends on the situation. We'll deal with that when it comes. After we isolate the squared part, we'll take the square root of both sides of the equation. When we do this, we'll have to put a plus or minus, and it says here, always there will be a positive and a negative answer. That's because when you take the square root of a number, for example, square root of 9, yes, 3 is the square root of 9. And the reason for that is because 3 times 3, or 3 squared, equals 9. But there's also another number that if you multiply it times itself gives you a positive 9, and that's negative 3. So negative 3 times negative 3, or negative 3 squared, is also 9. So 9 actually has 2 square roots. It's got a 3 or a negative 3. Now when we practiced simplifying radicals before, they were given to us in radical form, and when they're given that way, it's understood we're solving for the, or we're simplifying to the positive square root. But if there's no radical in the problem, so if you look at these problems down below, there's no radical here. We're going to insert a radical into the equation, or a square root symbol into the equation, in order to isolate the x. And when we do that, we have to account for the possibility that there are both of those answers, that positive and negative answer. After that, just depending on the type of problem, you may have to solve a little more to get x by itself, and I'll show you those examples down below. And then at the end, you can always check your answer. You can check it by substituting your answer back into the original equation, or you can use some different graphing calculator and solving skills in order to check your work there. And we'll talk more about that later as well. So let's get started with example 1. So we have x squared plus 4 equals 0, and I want to get this x squared part of the equation by itself. So in order to do that, I'm going to subtract 4 from both sides of the equation. So now I have x squared equals negative 4. So I've isolated the x squared. Now I'm ready to take the square root of both sides of the equation. So I'm going to square root both sides, and the square power and the square root are inverse operations, just like subtraction and addition, or multiplication and division. So the square power and the square root eliminate each other, and that gives us x on the left. And on the right hand side, we're going to take the square root of 4, and it's got a negative, so it'll have an I. So we'll have plus or minus 2i. And that's the answer for number 1. Looking at number 2, it's a tad bit more complicated. We have x squared right here, and we want to isolate that. We don't have any parentheses, but we do have some addition. So addition and subtraction come next, and we do have addition, so we want to get rid of the addition first before the fraction in the front. So I'm going to subtract 3, and now I have 1/2 x squared equals 9. So we don't have any more addition and subtraction in the problem, so now we're on multiplication and division. It's 1/2 times x squared, so I'm going to get rid of this 1/2 in the front. You have a couple of options here. You can either divide both sides by 1/2, but most of us do not love dividing by fractions, or you can multiply by the reciprocal of 1/2, which is 2 over 1. So I'm going to multiply by 2 over 1 to eliminate this fraction. I'm going to do the same thing on the other side. So these eliminate, giving us 1x squared. And on this side, I have 9 times 2, which is 18. Now I'm ready to take the square root of both sides. So when I take the square root here, the square power and the square root eliminate, and I have x equals plus or minus, don't forget your plus or minus, and then I'm going to simplify square root of 18. 18 simplifies, or 18 breaks down into 9 times 2, and so that'll give me 3 radical 2. You may see your answer given just x equals plus or minus 3 radical 2. Sometimes we also will get fancy and write our answer in set notation. Usually the smaller value comes first, and I'm using fancy braces. So the smaller of the, if I have positive 3 radical 2 and negative 3 radical 2, the negative one is the smaller one. It's usually listed first, and then positive 3 radical 2 is the other answer here. So you may see your answer given in just x equals plus or minus whatever format. You may see the answer given in this kind of fancy set notation if we're being true professional mathematicians. Now, if we look at example 3, we see that there's an x squared on both sides of the equation. So we want to try to get those x squares together because we can't isolate them if they're separated by an equal sign. So in order to do that, I want to be able to add this x squared over here, but I wouldn't be able to combine because I have this 2 times the quantity x squared minus 5. So in order to operate with these things, I'm going to have to distribute, and that's just kind of a unique situation. So I'm going to distribute the 2 to the x squared and the negative 5, which gives me 2x squared minus 10 equals negative x squared minus 1. So now I still have the x squares on opposite sides, and I want to add this x squared to the other side so those x squares can be together. So now I have 3x squared minus 10 equals negative 1. So my goal now is to isolate this x squared by itself, and so I'm going to add 10 to both sides of the equation. And that's going to give me 3x squared equals 9. Now I'll divide by 3, and that gives me x squared equals 3. And I'm ready to take the square root of both sides. So square root here and square root here. That gives me x equals, don't forget your plus or minus, and then just square root of 3. We can't take the square root of 3, and there's no perfect square factors inside of it, so that one's complete. You can either write it this way, or we could get fancy and say negative radical 3 and positive radical 3. All right, so the next one, in this situation we have parentheses, but notice that the whole expression is squared. This entire quantity is squared. So our goal is to get this entire thing alone. So attached to this, we have a coefficient that's being multiplied, and we have a number that's being subtracted. So the parentheses, we can't do anything with this parentheses because this is all stuck together by this square power. So we want to isolate this whole thing. That's not very easy to see when I just redo it with a highlighter. This whole thing is stuck together by that power because exponents are very strong. They're the strongest operation. So we're going to get rid of the other things that are stuck. So we could we couldn't distribute. I was going to say we could distribute. We can't distribute into a quantity that's being squared. So if this power wasn't here, we could distribute the 1/3. But if this power can't be evaluated and applied, then we can't move past that part of the process into multiplication in like the regular order of operations. And so we can't multiply before we apply that exponent. So we're gonna have to get rid of it instead. So first I'm gonna do the adding and subtracting. So I have -1, so I'm gonna add 1. So now I have 1/3 times the quantity x plus 4 squared equals 6. And this stuff is all still stuck together. So now I have to get rid of any multiplication and division. I have 1/3 times this. So I'm going to get rid of that by multiplying by 3/1. So these eliminate each other, and I have x plus 4 quantity squared equals 6 times 3, which is 18. Now I have isolated this squared quantity. This is weird and a little bit different because we're going to square root this whole quantity to get rid of this square power. So we're going to square root both sides of this like so, and the square power and the square root will eliminate and just dump this stuff right out of the radical. So I'm going to go over here, and that will just give me x plus 4 equals. And then don't forget your plus or minus, and we're going to simplify radical 18. That's 9 times 2, or 3 radical 2. Now up to this point, that's all we've had to do. We were able to just stop, and x was by itself. But in this case, x is not alone. We have our x's here, and there's a plus 4 attached to it. So we're going to have to also subtract 4 to the other side of the equation, and this is where a common error occurs. So please watch closely as we finish this up. I'm going to subtract 4 to the other side of the equation. Where it ends up going in this expression is a little bit tricky, so you need to pay close attention. I have x alone over here. I can't combine these two together because this is a rational number and this is an irrational number. They're not like radicals. And so what I have to do is just write the negative 4, in front of the plus or minus symbol that goes with the 3 radical 2. Okay, so 3 radical 2 is a single value. 3 radical 2 stays stuck together, and we have positive 3 radical 2 and negative 3 radical 2. And then we're gonna add negative 4 to both of those. And so the way that we show that is by putting it in front. So it's like negative 4 plus 3 radical 2 and negative 4 minus 3 radical 2. And if we split those, that's what they would look like. The two answers would be negative 4 minus 3, oops, I got a glitch there, minus 3 radical 2 and negative 4 plus 3 radical 2. So the negative 4 will go in front of the plus or minus when we move it across the equal sign. And that's a little bit tricky. That trips students up sometime. This next example is fairly similar. We have a quantity squared once again that we're going to isolate. We're going to divide both sides by 4 in order to make that happen. Again, we cannot distribute into a quantity that has an exponent on it. That is important to recognize. So we're going to divide to eliminate the 4 altogether, and that's going to give us x plus 5 quantity squared equals negative 16. Now from here, we're going to take the square root of both sides of the equation, and that's going to eliminate the square power and dump all this stuff out of that quantity. We're going to take the square root of negative 16, which gives us plus or minus 4i. And then finally, we're going to isolate x by subtracting 5 to the other side of the equation and putting it in front of the plus or minus. So we have negative 5 plus or minus 4i. Next example, I think I'm going to skip this one and let y'all try it on your own. So we'll come back to that in just a few minutes. I'm going to go on to number 7. Now don't tune me out on number 7 because I need for you to watch what I'm doing here. So we're going to divide both sides, same thing as we did on number 5. So now we have x minus 4 quantity squared equals 25. We're going to take the square root of both sides of the equation, and that gives us x minus 4 equals plus or minus 5. And you're probably wondering, what's so tricky about this? This looks pretty much exactly the same as what happened on example 5. Well, right here, we don't have an I. So when we bring this 4 to the other side of the equation, we have x equals 4 plus or minus 5. Now over here, we couldn't add the I, imaginary part of this expression, and the real part. We couldn't combine them into a single term. But we can add 4 plus 5, and we can subtract 4 minus 5. So that's how we're going to get our two answers here. We're going to do 4 plus 5, which gives us an answer of 9. And we're going to do 4 minus 5, which gives us -1. So our two solutions to this equation are -1 and 9. So that's a little bit different. The process was the same all the way to the end. If you get two integers, you just go ahead and add and subtract the two integers to find the two solutions. Hopefully you feel by now like you're ready to start trying some of these problems on your own. So we're going to work 6, 8, 9, and 10 independently, and then come back together to check our work. Pause the video now and see how you do. Here's number 6. X equals plus or minus 13i. Here's number 7. X equals plus or minus 7. Here's number 9. Multiply by the reciprocal to eliminate -3/5. X equals plus or minus radical 5. And here's number 10. Make sure you simplify radical 27 and bring out your I to get x equals plus or minus 3i radical 3. Now you're ready to start working on your own. Good luck!